Thank you for attending today's pivotal webcast. A quick orientation before we begin. Your audio is being streamed through your computer and speakers. Inside your audience console are application widgets that can be resized on your desktop, including Q&A, resources, help, and media. To expand your slide area, click on the maximize icon on the top right or bottom right corners of the frame. If you have any technical difficulty, please click on the help widget at the bottom of the console. We encourage you to ask questions throughout the webcast using the Q&A component, and questions will be answered either during the session by text or by the speaker at the end of today's presentation. To see responses for yours and other participant questions, click the Q&A refresh button throughout the event. And lastly, the resource list on the left side of your console includes clickable links related to today's presentation, including today's slide presentation. Enjoy today's webinar with Ken Bastani. Kenny?
Thanks, Amy. Hi, my name is Kenny Bastani. I am the Spring Developer Advocate at Pivotal. Today I will be introducing you to a reference architecture for creating a PageRank analytics platform using Spring Boot microservices. A little bit about me. Again, I'm a developer advocate on the Spring team at Pivotal. I'm currently writing a book about cloud-native JVM applications with Josh Long, and the early release is available today from O'Reilly Media. As a part of today's webinar, I will be introducing you to a reference application that combines multiple microservices with a graph processing platform to rank users on Twitter. We're going to use a collection of popular tools as a part of this reference architecture. The tools we'll use in order of importance will be Spring Boot, Neo4j, Apache Spark, Docker, and RabbitMQ. As a part of this webinar, we'll be going over the following topics. We'll start by doing an overview of the reference application, which ranks Twitter profiles using PageRank. To calculate PageRank, we'll be using a graph processing platform, which is an architecture that provides a job scheduling interface to perform graph processing jobs using Apache Spark GraphX. Next, we'll do an overview of the reference architecture and talk about how to build multiple Spring Boot applications that might resemble a microservice architecture. We'll take a look at code for creating Spring Data Neo4j repositories for managing our imported Twitter graph. We'll then take a look at how to schedule new PageRank jobs on the data in Neo4j, which we'll use to rank users. So let's do an overview of the problem we will solve as a part of our reference application. The problem we're going to solve is how to discover influencers on Twitter using a set of seed profiles as inputs. To solve this problem without a background in machine learning or social network analytics might be a bit of a stretch, but we're going to take a stab at it using a little bit of computer science history. The PageRank algorithm created by Google co-founder Larry Page was first used by Google to rank website documents from analyzing the graph of backlinks between sites. I dug up the original research paper on PageRank from Stanford for some inspiration. In the paper, the authors talk about the notion of approximating the importance of an academic publication by weighting the value of the citation. In the paper, I found a quote which best summarized how the PageRank algorithm works. And the quote reads, "The reason that PageRank is interesting is that there are many cases where simple citation counting does not correspond to our common sense notion of importance. For example, if a web page has a link to the Yahoo homepage, it may be just one link, but it's a very important one. This page should be ranked higher than many pages with more links, but from obscure places. PageRank is an attempt to see how good an approximation to importance can be obtained just from the link structure." The PageRank works by calculating the importance of a single vertex by analyzing only the link structure of the graph. Each incoming relationship is considered as a vote. PageRank is calculated in steps, where each step is an approximation of both. At the end of each step, a weight is assigned to each vertex. Each subsequent step applies a weight to outgoing relationships using an approximate value that was calculated for the vertex from the previous step. Here we have an example graph consisting of nodes and relationships. Each node has a degree of connections, inbound and outbound. The more inbound links a node has, the higher the weight that is applied to its outbound links to other nodes. We see that the red node, node B, is the most important node in this graph. We also see that node C, the second most important node, only has a single inbound relationship. This is coming from node B. This is the basis for how PageRank calculates the importance of nodes in a graph with only the relationships between nodes. So now that we know how the PageRank algorithm works, let's see how we can use it for discovering important profiles on Twitter. Twitter profiles follow other users to see their updates. We can use the same reasoning behind using the PageRank algorithm on citations to approximate the importance of profiles on Twitter. This reasoning would tell us that it's not the number of followers that make a profile important. It is measured by how important those followers are. So this is the problem that our reference application is going to solve, and we'll go over the important details of how to build this in our webinar. We'll end up with something that looks a lot like this table. The first thing we'll need to go over is a graph processing platform. So what is a graph processing platform? A graph processing platform is an application architecture that provides a general-purpose job scheduling interface for analyzing graphs. The reference application uses a graph processing platform to analyze and rank communities of users on Twitter. For this, we'll use Neo4j Maze Runner, an open-source project that I started that connects Neo4j's database server to Apache Spark. So this diagram illustrates a graph processing platform similar to Neo4j Maze Runner. We can see from the diagram that new job requests are sent from Neo4j to RabbitMQ. Before Neo4j sends a message to RabbitMQ requesting a new job, it will export a graph replica to HDFS. The analysis service, which is the hexagon that is colored in purple, has an embedded standalone instance of Apache Spark and will listen for messages from RabbitMQ containing new job requests. Each message that is received by the analysis service contains information about where the exported graph replica is stored on HDFS and which graph algorithm to execute. So after the analysis service has completed execution of a job, it sends a message to RabbitMQ that will be received by a listener on Neo4j. The message will contain a path on HDFS of the resulting graph that was saved by the analysis service. Neo4j will then import the results from HDFS back into the database without interrupting or impacting transactions that are being made by other database clients. The PageRank results from GraphX are going to be automatically applied back to Neo4j without any additional work to manually handle data loading. The workflow for this is extremely simple for our purposes. From a backend service, we'll only need to make a simple HTTP request to Neo4j to begin a PageRank job. So when we talk about microservices, we're talking about developing software in the context of continuous delivery. So microservices are not just smaller services that scale horizontally. When we talk about microservices, we're talking about being able to create applications that are the product of many teams delivering continuously in independent release cycles. In this reference application, I've built 4 microservices, each as a Spring Boot application. If we were to build this application as microservices in an authentic scenario, each microservice would be owned and managed by a different team. So this is an important differentiation in this new practice, as there's much confusion around what microservice is and what a microservice is not. A microservice is not just a distributed system of small services. The practice of building microservices should never be without the discipline of continuous delivery. But for the purposes of this reference application, I hope that it will give you an idea of how to compose complex applications as distributed systems that resemble a microservice architecture in a team environment. This diagram here shows each component and microservice that we will create as a part of this sample application. Notice how we're connecting the Spring Boot applications to the graph processing platform we looked at earlier. Also notice the connections between the services. These connections define communication points between each service in which protocol is used. The three applications that are colored in blue are stateless services. Stateless services will not attach to a persistent backing service or need to worry about managing state locally. The application that is colored in green is the Twitter crawler service. Components that are colored in green will typically have an attached backing service. These backing services are responsible for managing state locally and will either persist state to disk or in memory. We'll start by building the Twitter crawler service by creating a set of domain classes and repositories to manage data with the Spring Data Neo4j project. The Twitter crawler service will act as a REST API to interact with users we've imported from the Twitter API. We can see that this service has an HTTP connection to the Neo4j server. We'll also use the Twitter crawler service to schedule PageRank jobs with Neo4j. Those jobs are going to be dispatched for calculation on Apache Spark, which we see colored in purple. We'll start out by creating a set of Spring Data Neo4j repositories. The Spring Data Neo4j is a project in the Spring Data ecosystem that implements the Spring Data repository abstraction using an object graph mapping library. Spring Data Neo4j allows you to manage data on a Neo4j server using annotated POJOs as entity references in a Spring Data application. Before we can start managing data in Neo4j, we'll need to design and construct a graph data model for our application's domain data. The domain model for this application is rather simple, and we'll construct it using domain objects described in Twitter's API documentation. We'll only have one domain concept, which is a user profile, and we'll source this resource from profiles that are imported from the Twitter API. We'll then have a relationship entity with the type named follows. The follows relationship will connect user profiles together in Neo4j after importing follower data from the Twitter API. So the graph data model that we'll end up with looks like this diagram. We see here that we have three nodes having a label user and relationships between them having the relationship type follows. We can see that each of the user nodes have a set of properties. First, we have an internal node ID that is assigned by Neo4j. Next, we have a profile ID, which is a unique identifier that is assigned by the profile from Twitter. We also see that we have a set of properties for PageRank and screen name. The PageRank property will update as jobs are processed on Apache Spark. The results of the jobs are going to be applied back to the user node in the Neo4j database. So to represent this domain model as Java classes, we'll need to create two domain classes, one for the user node and one for the follows relationship. We'll then need to create Spring Data repositories for each of these domain classes. Let's start by taking a look at how to create a class that represents the user node, which is the profile that's imported from Twitter. We see here that we have a basic POJO that represents a domain class for the user node in Neo4j. We can also describe fields for incoming and outgoing follower connections. These fields will be created with the type setUser. And it's going to give us a way to load profiles that are connected to a user node with a follows relationship. At the top of this class, we have a node entity annotation. This annotation is used to mark this class as a Neo4j entity reference. So this class is going to be specific to the nodes that are in our Neo4j database. each domain class automatically will apply a label to Neo4j nodes in the database using the name of the class, in this case, user. The next annotation we'll need to add is the graph ID annotation. This annotation is used to mark a private field as an ID property, one that is automatically generated by Neo4j as a unique internally issued identifier. The next annotation we'll use is the index annotation. We'll use this annotation on the profile's ID field to indicate that it's a unique ID that we'll be using to make sure that duplicate user nodes are not imported from the Twitter API. The next annotation we will use is the relationship annotation. This annotation is used to indicate that a field references a set of nodes that are connected via relationship type and direction. So in this case, we can load a user's incoming and outgoing relationships to other users in the graph. And finally, we'll add in other fields that we will import from the Twitter API, as well as a PageRank field that will be added as a result of our Apache Spark jobs that are calculating a user's PageRank. So here we have a basic POJO that represents an entity reference for our relationships in Neo4j with the relationship type follows. The basic function of this relationship entity is to act as an index record that connects two records together from user A to user B. The annotations in this POJO differ slightly from the user entity in that the first annotation is relationship entity instead of node entity. This annotation includes a relationship type, which we've supplied as a parameter called follows. The next annotation is graph ID, and just like the user POJO, this entity is internally assigned as a unique ID from the Neo4j database. So next we have our two users, user A and user B. User A will be annotated as a start node, meaning that this user is following the second user. And the second user, user B, is annotated with end node. Next, we'll need to create a repository to manage our data that will be mapped to our user domain class. The Spring Data project makes repository-based management of database entities a snap. We're going to use the graph repository interface to create a repository bean that will be created at runtime in our Spring Boot application. So here we create a basic interface that extends graph repository. This repository interface will be initialized as a bean at runtime and provides us with a client to manage transactions on entities for user nodes in Neo4j. We'll also add in custom repository methods that take advantage of Neo4j's declared query language, which is named Cypher. Cypher is a query language that is designed to be familiar to users of SQL, but specific to the traits of a graph database. One example I've added for the purpose of this demonstration is the method getUserID by profile ID. So this query will match a user node using a profile ID parameter. When we download records from the Twitter API, it will often be the case that we only see a profile ID before downloading additional information, such as a user's screen name or profile image. So in this case, we want to get back the internally assigned unique ID that Neo4j has assigned to a node. And we can use this Cypher query here to perform a simple lookup that translates a profile ID to an internal node ID. So this reference application defines many custom Cypher query methods to extend the repository interface basic operations. Each one of these methods play a role in the crawling algorithm that allows the application to discover new users. So now that we can manage user nodes and follows relationships, we need to think about how performant it will be to save potentially thousands of relationships per second when importing user profiles from the Twitter API. We'll need to be able to batch transactions so that Neo4j can handle the throughput of ingesting writes at a rapid pace. To do this, we need to create another graph repository bean for managing the creation of many follows relationships between a set of user profiles. The repository interface here is similar to the user repository interface from the last slide. Here we have defined a cipher query method that will allow us to save batches of thousands of relationships in a single transaction. The result of this is that the user nodes will either be created or connected to other user nodes in our Neo4j database. So the cipher query here is fairly simple. For each of the instances of the follow class that are provided as a parameter to this method, the cipher query will either get or create the users that are referenced for the user A and user B fields. Finally, a relationship will be created between these two users if one does not already exist. So now we're able to save potentially thousands of users and relationships per transaction, which will be essential to the data import process from Twitter. So now we have our domain classes and repositories that we can use to manage entities in our Neo4j database. We can now import data from the Twitter API so we can perform scheduled PageRank operations on Apache Spark. So now that we've created our Spring Data Neo4j repositories for managing our Twitter follower graph, we'll need to expose a REST API interface that allows remote services to manage our domain data over HTTP. But thankfully, this is a simple task when it comes to using the Spring Data REST project. So all we need to do here is to enable this feature is to add Spring Data Neo4j onto our class path. And so we'll do that by adding the Spring Boot Starter Data REST artifact as a dependency in the project's POM XML file. This is all we need to do to enable this feature, and database resources will now be returned as a JSON representation that lists hypermedia resources as embedded links. So we can use these embedded links to manage resources of our graph repositories over HTTP. So now that we have everything we need to manage our Twitter profile data in Neo4j, we can import profiles from the Twitter API. To do this, we can use the Spring Social Twitter project. Spring Social Twitter is a Spring ecosystem project that allows you to manage Twitter API resources using a Twitter template client. The Twitter template client will take care of most of our concerns, such as API authorization, and provide client bindings that allow us to interact with Twitter's API resources from our JVM application. So going back to the architecture diagram from earlier, we can see that we have a dependency on the Twitter API from the Twitter crawler service. We'll call the Twitter API to import user profiles and their connection to other Twitter users. The results are going to be saved in Neo4j using the repositories that we created earlier. Before we can start using this client, we'll need to add the Spring Social Twitter artifact as one of our project dependencies in the POM XML, which is shown here. So in our Spring Boot application, we'll map configuration properties as key values on the class path. To do this, we will map keys in our application's property file to values that will be loaded from the environment. These environment-specific values represent the keys and access tokens that we will need to authenticate with the Twitter API. And we'll source these values to configure the Twitter template bean for our Spring Boot application. The next step will be to configure the Twitter client that is provided by Spring Social Twitter. In order to access operations for importing profiles from the Twitter API, we're going to need to provide API tokens and keys that are generated for an application by Twitter. So you'll need to register with Twitter and create a developer app in order to get these keys. But getting API access is pretty simple. We do provide a step-by-step guide on our Spring website that allows you to, will show you how to generate Twitter API keys for an application. So in this code example I've shown here, we'll use the value annotation to automatically load in configurations from the applications.property file. These are the keys that we saw from the last slide. We'll then define a bean for the Twitter template, which will require, as parameters, the Twitter API access credentials. So now we'll be able to automatically inject instances of the Twitter template that were initialized from our configuration properties during runtime. Now our Spring Boot application for the Twitter crawler service will be able to use the Twitter template object as a client to interact with the Twitter API. The code snippet I have here is a simplified example of how we will access a Twitter template bean using a Spring Framework technique called constructor-based dependency injection. This code snippet is only meant to illustrate how we'll be using the Twitter template client throughout the application. We can see that in this class that we're getting a reference to the Twitter template through the constructor, which will be called by Spring when initializing the bean at runtime. The last concern we need to address on our Twitter crawler service is to integrate with the graph processing platform. The graph processing platform is an attached backing service on Neo4j, which makes it easy for us to issue requests for new graph processing jobs. Neo4j exposes an endpoint to an unmanaged extension, the one that I created called Maze Runner, on the class path of Neo4j's database server. This unmanaged extension exposes a REST API for interacting with the graph processing platform's analysis service that embeds an instance of Apache Spark. So going back to our graph processing platform example from earlier, we can understand how Neo4j has been extended to be able to take incoming requests for new PageRank jobs. The only thing we need to worry about for scheduling new jobs from our consumers is to issue an HTTP GET request to the Neo4j server using a route that contains the analysis type and the relationship type we'd like to analyze. So it's easy enough to make a GET request to the job scheduling interface on Neo4j, but we still need to create a trigger that will be called on a scheduled time interval from the Twitter crawler service. To do this, we can use the scheduled annotation on a method of an object in our Spring Boot application. We'll then provide a fixed value for the rate parameter of the annotation that is measured in milliseconds. I've decided that the PageRank job should be started about every 5 minutes. So we'll initialize the fixed rate value here to 5 minutes in milliseconds. The snippet of code here is an example of how we will register a method using Spring scheduled annotation. This method will issue a GET request to a REST API endpoint on Neo4j. This method is described here by the relative path variable. We'll load in our environment-specific host name of the Neo4j server to generate the full URL to the job scheduling interface for Maze Runner. And finally, we'll make a GET request to the analysis endpoint. So now that we've gone over the major functionality of the Twitter crawler service, let's go over how to create a user interface that will display our ranked users. We'll call this service the ranking dashboard. So we're finished creating the backend components of the microservice architecture and can now write a simple client-side web application to interface with the Twitter crawler service. We'll need to be able to access the Twitter crawler service's REST API as a part of the dashboard's host. For this, we'll need to create a reverse proxy to the Twitter crawler service's REST API. Since we're using Spring Cloud, we were able to take advantage of the Eureka Discovery Service and the Enable Tool Proxy annotation to automatically inject routes from the Twitter crawler service into our new ranking dashboard service. So what this means is that the new ranking dashboard service will be able to expose the full REST API of the Twitter crawler service on its own host without writing a single line of code. So for the ranking dashboard, it's as simple as it gets here. So we'll create a Spring Boot application that has these annotations, Spring Cloud application, and Enable Tool Proxy. So this enables the basic Spring Cloud features for connecting to a discovery service. We've also added the annotation here, Enable Tool Proxy, which will enable an embedded tool proxy in this service. To get this to work, we need to worry about some configuration properties in our application YAML file. The properties here are configured for the production Spring profile and will provide the necessary settings to connect and register with the discovery service. Since the Twitter crawler service we created earlier uses the same discovery service connection settings, the ranking dashboard will automatically create a proxy to the Twitter crawler's REST API. Now when the ranking dashboard service is started, it will contact the Eureka Discovery Service at the service URL's default zone property, which we can see here. By doing this, we're able to embed the request mappings that are exposed by the Twitter crawler service. The ID that the Twitter crawler service will use when registering with Eureka will be Twitter-rank. This ID will be used as the request path to access the routes of the Twitter crawler service from the ranking dashboard service. All the requests to the route with the ID Twitter-rank from the ranking dashboard service will be forwarded as a request to the Twitter crawler service. So this is a pretty nifty feature. We can create a local request mapping to any remote service that is registered with our Eureka Discovery Service. And this comes in handy if you're working in a microservice architecture. The next step will be to add a static web content to the ranking dashboard service that connects the REST API of the Twitter crawler service through our newly embedded tool proxy. I created a simple client-side web application that uses jQuery to make AJAX requests to the Twitter crawler REST API. Spring Boot makes it easy to map static content by placing it in the resource directory of our application. The example here shows the directory of the ranking dashboard application. The static content for the single-page application has been placed in the resource directory under the folder static. Now when I run the Spring Boot application, the index.html file will be mapped to the service's root. Now we can start up all the applications in our architecture one by one. I've already gone ahead and done this for the demo so that we can explore the working application that has already imported records from the Twitter API. But first, let's take a look at what I did to train the data set that we'll see in the demo. The dashboard here is a single-page web application which consumes two REST API methods on the Twitter crawler service. Let's first review how the dashboard will be used. So the first time the dashboard is loaded, there won't be any data to display from the Twitter crawler service. Before the Twitter crawler service will begin to automatically discover new profiles, the user must provide a minimum of 3 screen names of Twitter users as seed. So the goal here is to add 3 seed profiles of users who are members of a community on Twitter. The one important thing to remember here is that you should want to make sure that these users follow each other, that they're a part of this community, that you want to discover other users who are similar. So the seed profiles I've chosen for this demonstration are myself, Star Buxton, which is Josh Long, and Bridget Cromhouse. So these are a few of my teammates at Pivotal. So when adding new seed profiles to the UI, an AJAX call will be made as a GET request to a proxied REST API path. So this path will route requests to the Twitter crawler service and respond as if the method was inside our web application. So after adding each of these profiles manually through the UI, we'll end up with the view that we see here. We can see that we've imported the profile attributes of each of the seed profiles. These are indicated in the ranking dashboard, but the PageRank has yet to be calculated. So if you remember from earlier, this job is scheduled every 5 minutes, so we're going to have to wait. So what's happened up until this point is that we saw earlier with our domain model, here again, it's an example graph data model that we use to create our Neo4j domain classes and repositories. So in this model, we see the 3 seed users I've selected. The relationships for these users have now been imported from Twitter. They also have relationships to many other users, which have also been imported. So this will be our training data set that we'll use as our discovery algorithm to find new users who are in our community. And we're going to use PageRank as the metric of relevancy to prioritize which users that will crawl next in the current data set. So now that I've added these 3 seed profiles, each of these users' connections will be imported to Neo4j on the Twitter crawler service. After about 5 minutes, the PageRank job will have been scheduled and completed its analysis of the initial users. After a PageRank value has been assigned to the initial users, you'll see new users that have been automatically discovered. The screenshot that I have here shows users that were discovered automatically by the Twitter crawler service. Newly discovered users are indicated by a green plus icon in the rank column. So these results are highly appropriate to the seed selection. We can even infer that the original 3 users have distributed systems development and DevOps as a common interest. Okay, so now let's go ahead and explore the working application. So I've gone ahead and already fired this up, and it's been running for a while. So what we'll do first here is to look at how many nodes and relationships we've imported. So this has been running since about 6:30 this morning with a short downtime period here. We can see that we have 500,000 nodes, and we can see this number that is increasing over time. That means that we're still importing new users. And we have about 1.1 million relationships. So now if I go to the dashboard page here, we can see that I've added these 3 seed profiles. Now below we can see that we have a lot of users now. I'm just going to refresh this. Okay, so we're over 100 now. So over time, it's going to import new users. And every time it does that, it's changing the configuration of the graph. So every time a PageRank calculation is applied, it's going to change the ranking of users. So they're going to go up and down. And so what we'll end up having is that for each PageRank operation, we'll have a snapshot from the last PageRank that was run to the current PageRank. And so we can see the change over time to see whether or not a user is moving up and down. Let's see how far I'm down the list. So I'm here at 83, and you can see my PageRank value. And let's see where Josh is. We can see Josh is 46 here. And not too far behind, we have Bridget. And let's see who's at the top here. We'll just open that in Twitter. So we can see that there's 62 followers that I know. So this means that we're probably on target here. Now, what's cool about this algorithm that I discovered is that it's highly relevant. So all of these users are people that I either know or are in a community of people that I've yet to discover. And there's no, I have yet to find in a result set of 100 a user that's really outside of these boundaries. So as you can see, there's no spam accounts in here. There's not even any companies in here. So they're all people. So I think that's pretty interesting that it's only importing people rather than importing a company profile, for example. So if we go to our Neo4j database server, we can actually look and see what's inside. So here we see that we have our user nodes. And if I go ahead and click this, I can see here, I was selected at random, really. I think I might have been the first user that was added. And we can see that I'm connected to a subset here, which is limited at 25. So these are the users that are waiting, these users without any information attached to them. These are the users that are waiting to be discovered. And so the user that is most relevant to be discovered next is going to be imported from the Twitter API, and then PageRank is going to be recalculated. The one last thing I want to show you is this reverse proxy on the ranking dashboard. So I'll go to my REST client here. So I already know what the ports are here, and 8080 is going to be the Twitter crawler service. So if you remember, this is our data service that imports the users from Twitter and saves them to Neo4j. So we can see here we have hypermedia resources, which are exposing management capabilities on our Neo4j database. So if I go to the following link, I can see that we have these relationships where I outlined earlier, we have user A and user B. Now if we go back and choose users, take a second. I'm actually going to cheat and use a better REST client. So let me go back to that. Users. That still might take a while. So I don't have paging and sorting enabled, so I'm probably clearing all 500,000 users. Not a good idea. But what I want to show you is search capabilities. And so if I go ahead and refresh this. Okay, so postman return. So here we have our users that return, which as you can see is quite a bit. But the thing that's interesting here is this search endpoint. Gotta go. Okay, so I'm going to the user search endpoint here. So this is a link that describes some of the custom methods that we created in our repositories. So this one is our user repository, and we created a couple different cipher queries that map to these methods. Now, why this is relevant is that the ranking dashboard will have these routes available on its own host. So 8081 here, this is our ranking dashboard. And we have the Twitter-rank route. Actually, if we go to the routes endpoint here, we can see that we have this mapping Twitter-rank. And so now I can issue AJAX requests to my own host for the ranking dashboard. And I don't have to call across or do any extra manual effort to make this call to the other service. And so that's about it. I guess I will pass it back to Peter now for questions.
Hey, Kenny. Yeah, no questions at the moment. I think, and my Q&A panel just froze up, actually, but there weren't any questions as of when I last checked. So I'll just wrap up real quick. I think just want to let people know that we will be posting the recording to spring.io/video. And that will just redirect you to the YouTube channel and spring.io blog within the next 2 weeks. If you'd like to get a notification about the webinar replay being available so you can share it with your coworkers or use a YouTube downloader to watch it on a plane or something, we recommend you subscribe to the YouTube channel directly, or better yet, subscribe to the Atom feed from the spring.io/blog, because then you'll get all the awesome blog content from the rest of the Spring team, as well as notifications about future webinars and webinar replays. So we will be having another webinar pretty soon on NetBeans and Spring. Stay tuned for the date announcement on that. It's very likely to be in February. And we'll post that on the spring.io blog. Lastly, just note that if, in terms of getting a hold of, Spring Data Neo4j binaries or other Spring binaries, while we strongly recommend that you use Maven and Gradle for that, if you're in a situation where you absolutely need HTTP downloads, maybe you're behind too many proxy servers or on a closed network or something, you can get them from our Artifactory server, and that is located at repo.spring.io. So again, with that, actually, looks like one question did just come in from Henrik. So Kenny, could you explain the role of the discovery service?
So this discovery service here, here's the architecture again. So the discovery service is going to allow applications to check in at runtime. So when the application starts up, it's going to contact the discovery service. It's going to provide information of where it can be contacted dynamically. Now, what this allows us to do is a lot of interesting things with Spring Cloud, one of them being client-side load balancing. The other is to be able to access another service, a service dependency, just using an ID. So from the Twitter crawler service, all I need to know is the ranking dashboard ID, and I'll be able to access that. And I don't have to manually put in our configuration for the Twitter crawler service where that service can be contacted.
Excellent. Thank you so much. All right, folks. Last chance. Any other questions? And while we're waiting, just realize that there's some follow-up resources. If you look in your user interface for the webinar, you'll see a Resources tab. And before we disconnect the webinar and close out the event, I recommend you go in there and click on any of the links that you'd like to get for follow-up information, like the slides or Kenny's GitHub URLs for the source code for the examples, et cetera, et cetera. So please do take a moment right now to go to that Resources tab, and those are clickable and pop open some browser windows for anything that you're curious about following up on. By the way, Kenny, Henrik, who just asked the previous question, did just ask a follow-up, and he said, hey, great, is this a Spring-specific API for the discovery service, I mean?
So this is Eureka, which is a Netflix OSS project, but this is included as a part of a Spring Cloud project.
So I think maybe just to add a little bit to that, you know, you can certainly use Eureka Vanilla. We just make it quite a bit easier, right, with Spring Boot. So
yeah, all you have to do is add an annotation.
Exactly. We make it quite a bit easier to use. Correct me if I'm wrong, Kenny, is it a REST API that they use for Eureka straight with Netflix open source?
Yes,
okay.
That's correct. Actually, I can go to that real quick.
If that's the case, you can use. If that's the case, then you know you should be able to use Eureka from any language. But if you're using Spring and Spring Boot, we're going to make it a heck of a lot easier for you. So hopefully, Henrik, that addresses your question. Another question comes, and he asks, "Hey Kenny, how many references could be gathered by the Twitter API in your example with your account? Is there any limit?" And I think the answer is just that this kind of depends on Twitter's rate limiting, right?
Yeah, so this is actually a big part of the application, and I talk about this a lot in the blog post. It's not something that I wanted to get into as part of the webinar, but I'm using AMQP and RabbitMQ to durably import these records, and I'm optimizing, I'm playing the rate limiting game. So over time, you'll get a certain amount of requests in a certain window. And you want to make sure that you're importing the most data you can in that window. And so, yes, that's a big part of this. And if you check out the blog post, you'll see a lot of information on how that's done.
And again, folks, I believe there's a link to that blog post in the resources tab of your webinar user interface. So now is the time to go check out those links and click on them before we actually close out the session. Oh, and I should mention that when we do post the replay, of course, we will also post a link to the slides in the description of the YouTube video, as you know, as well as perhaps a link to the blog and maybe the GitHub URL and such. Great. Another question from Miraj, or a question from Miraj, I should say, and he asks, "Hey, why Neo4j only? Would you recommend any other graph database that's as good as this one?"
No, I wouldn't recommend another graph database right now, although there are options. I'm partial to Neo4j a little bit because, well, first of all, I love it, and I was the developer evangelist up there for a few years. And I think that Neo4j has a lot to offer. Also, it's a Spring Data Neo4j project. We don't have any other graph databases right now that are in the Spring Data ecosystem. So that's why we're having to use it here.
Makes sense. Yep. Yeah, I'm not aware of too many other graph databases myself. I know Neo's always sort of been a leader in that area, but I mean, I'm sure there are others. But yeah, certainly, as you said, that's the only one that Spring Data has a repository abstraction for. Great, folks. All right, well, last call for questions. We got a couple minutes left before the top of the hour. We can give those back to you if there are no more questions, but just want to send a last call. Oh, great. Okay. Another question from Frank. And he asks, does Neo4j have good support for sharding?
No, it doesn't. Simple answer. Neo4j doesn't shard.
Every once in a while, there's a simple answer in technology, right, Kenny?
Yeah, right.
Okay. All right. So I think that kind of wraps it up, folks. Like I said, check the Spring.io blog. We are going to be doing a webinar soon on NetBeans and Spring, so that should be exciting for all you NetBeans users out there. If there are any NetBeans users out there. So wonderful. Thank you guys so much, and girls so much for coming. We really appreciate your time, and please, express your thanks to Kenny on Twitter. You can follow him at Kenny Bastani. I think. Kenny, if you want to pull up your intro slide there real quick with your Twitter handle on it, that would be cool, so they can follow you on Twitter.
Yes.
And tell you how much they loved this webinar. That would be very cool. If
you hate it, I'll take criticism. Well, I'll take anything I can get.
Oh, that's funny. One of the people said, "Long live IntelliJ." That's kind of funny. All right, great. Well, listen, thanks everyone for your time. And Kenny, anything you want to say to wrap this up before we close out the event?
Nope, that's it. Thank you, guys.
All right. Have a great day, everyone, and thanks. And I hope to see you at a webinar again on the Spring Channel real soon. Take care.